Hello, my name's Adam Braden, and I'm a program manager on the Windows Developer Platform team. And today I want to talk to you about CSWinRT, which is the new tooling we're using to provide Windows WinRT API support for .NET 5 applications. Okay, so for our agenda today, I want to go over what is CSWinRT and what it means to .NET 5 developers. I'll also show you how to access Windows APIs now that are done differently through .NET 5 via the target framework monikers. And next, I'll show you a couple of demos on what it means for C++ runtime component developers and what changes they'll need to make to support their .NET 5 customers. And lastly, we have some new support in our CSWinRT tooling, which will allow C# customers to build runtime components that can be hosted in non-.NET environments, such as C++ or Rust or even Python. So first off, why is CSWinRT needed? Well, what we first have is .NET 5 has moved to a new model where they're implementing platform API support in a uniform way across Windows, iOS, and Android. By doing that, they're lifting support out of the C# compiler and the .NET runtime and decoupling it from the compiler and runtime. That allows them to focus on creating a optimized cross-platform compiler and runtime for .NET. And it also means that platform API support for Windows, iOS, and Android will have to use their own tooling to build that projection support. The thing that allows us to do now on the WinRT side is to build our projections independent of .NET, meaning we can add new features, performance improvements, as well as .NET 5 bug fixes to the projection assemblies, increasing our ability to turn around bug fixes for the projections. So what is CSWinRT? CSWinRT really builds that .NET 5 interop assemblies from a Windows metadata file. It is simple tooling that reads in an input file and outputs C# code. That C# code is then compiled into a projection assembly. It also includes a runtime DLL that adds low-level interop support and lifetime management for that interop assembly. With CSWinRT, you can also create C# runtime components that can be hosted in those those non-.NET languages. The other thing we're doing with CSWinRT is because it's decoupled from .NET, we're also building it open source on GitHub. This allows our tooling to evolve independent of .NET 5, and you can see the progress we're making on GitHub. Lastly, this is the tooling that we used to build the .NET 5 target framework support that was added to the .NET 5 runtime to support Windows. So let's take a closer look at Windows APIs and what it means for your .NET applications. First, if you're a .NET Framework app or a .NET Core 3 application, there's no change for you whatsoever. You can continue to use the Windows SDK contracts NuGet package, or you can reference the Windows WinMD file that's part of your installed SDK. There's no changes required there. However, if you're migrating the app or writing a new app to .NET 5, there's a simpler method you can use to access your Windows APIs. .NET 5 has introduced a new set of target framework monikers that support .NET 5 and Windows 10. Here we have support for 3 different versions of Windows, the last 3. 17763, which was build 1809, 18362, which was Windows 1903, and 19041, which was Windows 2004, just released this past spring. What is happening under the covers? How do you actually get the API support? What does this target framework moniker mean? The target framework moniker is an optimized way that pulls in the Windows SDK framework references that are part of .NET 5. What that does is it pulls in the Windows SDK.NET projection assembly that provides all that interop support for C# to call into those Windows APIs. It also includes the WinRT runtime DLL that's required for all CSWinRT projections. So by referencing the target framework, you have all the dependencies you need to call your applications. So let's review how to call Windows APIs in .NET 5. Let me switch over to Visual Studio. And here you'll see that I have a simple Windows WPF application, and it leverages some Windows APIs to take a picture with the webcam, something that's kind of hard to do with .NET today. And also I have another text block here where the button goes ahead and gets some system information about my PC. Specifically, it gets the hardware identifier and some information about what flight rings and the display adapters that are connected to the PC. Taking a look at the code, you can see that I'm referencing some Windows APIs, and I have some various namespaces to accomplish the task that I've set out. For capturing the web camera, I'll use the media capture class, and I have some code here that initializes it, tells it what type of format I want to capture, tells it where I want to store the file, and then it calls the API to actually capture the photo. Once the photo is captured, I can then load it as a bitmap from a file and load it into the WPF image control. The next button then goes through and uses additional Windows APIs to get a system identifier for my specific hardware that's based on the TPM. I then check with the Analytics Info APIs to get the Windows Insider preview settings for this particular PC to confirm what flight rings it is on. I then gather some additional information with the device information APIs about how many displays are connected to this PC and if they're connected via HDMI or DVI. Let's see how I'm accessing or building this application right now. Currently, you'll see that it's a .NET Core application, version 3.1, and that in order to access those Windows APIs, I'm using the Windows SDK Contracts NuGet package, version 19.04.1. So that's all I need in order to call and access these APIs. Let me go ahead and verify that it works. As it starts up, you'll see that I have a button here. I can click Take Picture. And you'll see that it was able to capture a picture of my webcam. And then it also got information from my PC. I'm only displaying the first 10 digits of my system ID. I'm enrolled in Windows Insider Flights, the external ring, and that I've got two displays attached, a HDMI display and a DVI display. Great, let's go over what we need to do to change this over to .NET 5. It's as simple as changing your .NET target framework. You notice that I'm specifying .NET 5 with the Windows 10 framework moniker, and I'm specifying the same SDK version that I want to reference as part of my APIs. This target framework moniker pulls in the framework reference assemblies for the Windows SDK that are the equivalent projection assemblies for the old SDK contracts. Since I'm using .NET 5, I don't need the SDK contracts anymore. You'll also notice that I have a framework reference down below. This framework reference is to work around a bug in the current release. This release will be updated with RC1, which will be out before Ignite, and so you won't need this framework reference. Let me go ahead and run this. And you'll see that now I have a .NET 5 application that looks and behaves the same way. I'll go ahead and take a picture. And I'll call my system information. And you can see the picture was taken and the APIs work the same. Now let's say, for example, you have a .NET Core 3.1 application and a .NET 5 and you need to support both. Well, fortunately there is a way that in .NET 5 you can use multi-targeting to accomplish this task. To accomplish that, you need to use the Target Frameworks moniker and specify all the versions of the target frameworks you wish to support. In this case, .NET Core 3.1 and .NET 5. In order to do this, I'll also need to include my package reference for the .NET Core 3.1 application. However, I need to add a condition statement that says only include this reference when I'm targeting .NET Core App 3.1. And that's it. Those are the two changes I need to make in order to have my application run. I've noticed that when I switch between Target Framework and Target Frameworks, that Visual Studio asks me to reload the projects. I'll go ahead and do that. And now I can run. But before I run, let me show you that now I have a choice in my debug dropdown to switch between .NET Core App 3.1 and .NET 5. I'll go and stick with the .NET 5 version. And we'll go ahead and just run the system information APIs to say the same app is running here. Go ahead and close this. And now if I want to, I can switch back to .NET Core 3.1, and I will run this, and you'll notice the same application is working on .NET Core 3.1. So there, I've showed you how to modify a .NET Core 3.1 app to target .NET 5 and remove the reference to the Windows SDK contracts because the new TFM provides that support for you. I've also showed you how to update to multi-targeting by specifying both the .NET Core 3.1 target framework as well as the .NET 5 Windows 10 target frameworks. And you can use a condition statement on your package reference in order to get the appropriate references for the appropriate target framework. All right, so there I just showed you how to call Windows APIs in .NET 5. Let's take a look at the next step of component authors and what they need to do in order to support .NET 5 and C#WinRT customers from a C++ runtime component. When I build C# runtime, C++ runtime components, what's really different here? When you build a C++ runtime component, you build a projection. You need to build a projection assembly. By that, you take the WinMD file that's part of your C++ runtime component. And then you need to run CSWinRT against that component to build your interop code. CSWinRT, its whole job is to read a WinMD file and output interop code. Once you've got the interop code, you now need to compile it into a .NET 5 runtime DLL. And this is what we call your projection assembly. Once you've got that projection assembly, you now need to update your NuGet package. Your NuGet package already contains the WinMD and the DLL, the implementation DLL for your component. The WinMD is needed for your .NET Framework customers, .NET Core customers, C++, and Rust as well. You also need the implementation DLL in order to use the component. What's new now is you need to add a new target framework library for the projection to use from .NET 5. Let's go ahead and go through a demo of what it looks like to update a C++ runtime component and build a projection assembly and update your .NET, your NuGet package. What I have here is a simple C++ WinRT component that's written in C++. And I've got a simple IDL file here. This IDL file is compiled by C++ WinRT into a WinMD file. That WinMD file is used for cross-language interop between C#, C++, Rust, and other languages that support the Windows runtime. I've also got the implementation and header files. There's nothing new here or special about this component. It leverages CPP WinRT, and it's available you can build that using today's technology. What's new, however, is .NET 5 customers require a projection assembly. So I'm going to show you how to build a .NET 5 library that includes that projection code. Ideally, you'd be able to reference or able to build a projection assembly using a .NET 5 library project. And all you need to do is reference CSWinRT in order to get the tooling to support that. You'll also need to reference the Microsoft Windows SDK the Microsoft Windows SDK projection assembly in order to get all the different types that are referenced by your component. Lastly, you'll need to reference, add a project reference to the C++ component that you want to build a projection for. Now, long-term, our tooling, this is all you'll need to do. You'll be able to hit build, and build will create the projection code for you and then compile that into an assembly. However, the tooling isn't quite there yet. We expect that tooling to happen in the October timeframe. And so what I'll do is I'll walk you through some steps for what you can do to build this yourself. This is all documented on our docs and repo site. I'll just give you the quick overview here. The first thing C# needs is to identify the WinMDs that are referenced by this project, this library project. And so it goes through and keeps track of all the reference WinMDs that are in this project. It also needs to remove them from the MS Build targets because currently it's an error for .NET 5 applications to have a reference to a WinMD file. Because C# and .NET 5 do not include support for WinMDs, we're actually building it here, but we're building a .NET 5 assembly. So we've got to do a little magic to keep track of the WinMDs, but remove them from MS Build so MS Build doesn't give us an error. The next part is the one project property that you as a runtime component author will need to set. This tells CSWinRT which namespaces to include in the projection. This is for scenarios where you have multiple assemblies you're referencing, and you need to specify which projection you're actually creating. The next step here is specific for CSWinRT to build a response file, and the response file is a set of command line arguments for what CSWinRT uses to build its projection. You can see that I'm going to target framework here for .NET 5. I'm referencing a specific SDK to get references to the WinMDs. I'm going to reference the WinMD that my project is actually referencing. And then I use that namespace to include to tell it which namespaces to include in the projection. I'll show you what that looks like in the output here in just a second. After CSWinRT generates the source code, you actually need to compile that source code into a projection assembly. This step here takes that source code and actually calls the C# compiler to build that projection assembly. Again, all these steps will be transparent to you in a coming preview. I'm showing you the steps now to help you build it yourself. To take a quick look at that the response file that CSWinRT uses to build that projection code, this is what it looks like. You'll see that I'm targeting my app as targeting .NET 5. I referenced the Windows SDK folder for 1903. And then here's my reference to the WinMD file, which comes from my C++ WinRT component, simplemath.winmd. And then I build a projection file called, including the namespaces simple math component. I'm also making sure I exclude the Windows APIs because I'm not building the Windows SDK itself. So that's the response file. When I build this, let me go ahead and build it. I'll go ahead and rebuild here. And so what it's doing is it's referencing the WinMD file, it's referencing the SDK to make sure it knows about all the types that I could be using, and then it's building that C# code that is the projection assembly. You can see the C# code here that it output. You'll see it has an interface that matches my C++ code for add, subtract, multiply, and divide. And it exposes that via a public class that I can access in any .NET assembly now. So this code was compiled. Let me go ahead and go to the output folder. And show where it lives. So you'll see that it has the projection DLL it's built here, and it also includes the simple math component implementation DLL and the WinMD or the metadata file. Once I've got this projection assembly, now I need to update my NuGet package so customers of my component can consume or use my component. What does the NuGet package look like? The NuGet package has targets for different versions of platforms that it supports. Currently, it supports .NET Core 3 and UAP 10, or UWP, as well as .NET Framework, and those components all reference the WinMD. What's new is I have to update my NuGet spec to include a target for .NET 5, and for .NET 5, I reference the projection DLL, not the WinMD. Lastly, this is common for all NuGet or runtime components. I specify the runtime, which is the actual implementation of my component. The other dependency for .NET 5 customers they need to add is they need to add a dependency for the CSWinRT in order to get the runtime DLL that all .NET 5 customers or all .NET 5 components require. So once I build this NuGet package, I'll have a .nupkeg file, and I can reference this NuGet package, publish it to NuGet, or reference it locally. For the purposes of this demo, I've gone ahead and created a simple C# console application. And in the C# console application, you can see I've referenced my simple math component NuGet package. This NuGet package is based off of a local feed that points to that .nupkeg file. And here is that package reference for that NuGet package. Because this is a C++ WinRT component and I'm using it in a .NET application that is not packaged, I'll also need to include the VC libs, or the VCRT forwarders that reference the VC framework that's installed locally on the machine. Now, once I've added a reference to the simple math component, it's just like any other .NET framework assembly reference. I can go ahead and build code against it. Here you can see I've written new code to initialize the component, or initialize the class, and call the add method. And I'm simply adding 5.5 plus 6.5 and writing the output to the console window. Let's go ahead and run this application and see how it works. I've hit a breakpoint. Let me step over those breakpoints. And you can see in the debug window, I've gotten 12. And if I go to my console window, I've also gotten 12. And quick math in my head, 5.5 plus 6.5 equals 12. So there you go. I've shown you how to add a projection assembly to your C++ runtime component. That projection assembly is built in C#. I've shown you how to update a NuGet package that includes that projection assembly for your .NET 5 target customers. And I've also shown you how to call that runtime component from a C# application. Let's go back to our presentation and take a look at the next step. First, in order to build C# runtime components, the first thing you need to do is author your assembly. It's a typical C# code file where you declare your classes and implementation, just like you would any C# library component. You need to make sure that your public surface area adheres to WinRT runtime types. Once you've got that assembly or that source code ready, you then reference CSWinRT. CSWinRT will do the heavy lifting behind the scenes, leveraging .NET 5 source generators to build a WinMD file and the implementation assembly. This is different than C# runtime components previously in the Universal Windows platform. Previously, those runtime components built a combined WinMD file that included the WinMD plus the implementation assembly as part of a single file. Now, however, you'll have both files, the WinMD and the implementation assembly. So CSWinRT, the tooling, handles all that heavy lifting for you. It includes your source code, and it generates a projection wrapper classes built via source generators to compile your assembly and generate the WinMD file. So now that you've got your C# runtime component, you need to host that component in a native application. In order to host that component, you also need to host the .NET runtime itself. CSWinRT includes a set of tooling that actually includes the .NET 5 runtime hosting support. It's a new component called WinRT host.dll. In your C++ app, you reference the WinRT host.dll, and it knows how to find your implementation assembly. This hosting support is supported in packaged applications, meaning your packaged Win32 or UWP applications. It's also supported in unpackaged applications via Fusion Manifest or what we call manifest free, where you follow a certain naming convention and it can load your assembly. Let's take a closer look at what those demos look like, and I'll show you how to build a C# runtime component and how to reference the hosting library in order to host that application or that component inside of a C++ application. If I go to Visual Studio here, you'll see that I have a .NET 5 library project, and it includes two classes. It has a simple random, it's called myRandom, and it has a couple of classes. One is message of the day, and it's just a simple list of some common phrases I've heard growing up about life. And the message of the day will just randomly choose one of these two messages to display. The other class is similar in that it's a random number generator. It's got a method to give an unbounded random number, and also you can specify a range to generate a random number for. Now, if I'm only building a .NET assembly and my only customers are .NET, I don't need to do anything special. I just build this library as is and hand it to my customers. However, if I want this assembly to be used in other languages like C# or C++ and Rust, then I need to build a Windows runtime component. So in order to do that, what you'll need to do is go ahead and make a reference to CSWinRT. This will pull in the various tooling and tooling required to build that projection assembly. You'll also need to set a new property to build a runtime component called CSWinRT runtime component and set that to true. Once you do that, you'll have all the tooling will be kicked off in order to build wrapper classes that wrap your C# code in projection wrappers and build that assembly that can then be called from .NET components. Let me go ahead and build this just to prove that it rebuilds. And so that worked. Now what I want to do is I want to reference this component from my C++ test app. So my C++ test app has a reference here to my random component. It grabs the WinMD and the reference assembly. There's a couple things you need to do in order to be able to hook this up. First, when you reference the WinMD, you'll notice I also need to reference CSWinRT. I believe my reference is, and you'll see that in the packages config here. That's required to call any runtime component from C++. C++ then generates the header files required to get IntelliSense and the code for your projection as part of your C++ app. Once you've run CSWinRT against your referenced files, your referenced WinMD files, you can then write code that feels natural in C++ to call your runtime component. Here I'm initializing the number generator and calling a couple of the getInteger and getInteger within range methods. I'll also initialize the message of the day and display that to the output as well. Before I do that though, it won't work as is. It can't find the component. It doesn't know where the metadata is, and it doesn't know where the projection, or excuse me, the implementation DLL is. And so we have to help C++ apps know how to load this .NET assembly. And there's two parts. There is the WinRT host. Remember earlier I mentioned that we have to have this WinRT hosting DLL that is actually the .NET 5 hosting engine. Then this WinRT hosting DLL, you have to tell it which classes it needs to support. The WinRT hosting DLL then looks for it initializes .NET 5 runtime, and then it looks for a DLL that matches the namespace of the class that you're trying to register. In this case, it'll look for myrandom.dll in the project output. So you'll notice that this is not a packaged app, and I'm trying to call a runtime component. Typically that fails. However, because I'm using the Fusion manifest that includes the registration for it, this will succeed. Let's go ahead and confirm my assumptions. And voila, we have a C# code or C++ code here calling a C# component that's hosted in .NET 5 by the WinRT runtime or WinRT host DLL that looks and loads that C# component and then calls the methods on it. And you'll see that I've got a random number between an unbounded integer, and I've also returned a random number that's between 0 and 10. And the message of the day is a fool and his money are soon parted. So the tooling support here for C# runtime components is something we expect to have complete in the October timeframe. be available in preview at that time. We're currently working, and we've got the end-to-end scenario working. We're trying to continue to flesh that out right now, and we expect to have that wrapped up very soon. Let's summarize. In today's demo, I've showed you how to upgrade a .NET Framework and .NET Core application to .NET 5, and how to access Windows APIs using the new Target Framework monikers instead of the Windows SDK contracts package. I've also shown you how runtime component authors use CSWinRT to build a .NET 5 projection. And it shows you how to upgrade those NuGet packages to include that .NET 5 projection for your .NET 5 customers. Lastly, I've shown you how to use how to build C# runtime components that are now available in the latest preview of the CSWinRT tooling. For more information, you can always reference our aka.ms/CSWinRT to get access to the latest information about our tooling.